Okay, welcome everybody to Globus Office Hours. My name's Bridget Rauman, and I'm going to start Office Hours today with a short talk about what data Globus stores and how we protect that data. Globus is a nonprofit service that's developed and operated by the University of Chicago, so we are a part of the university. We aren't a separate entity in any way or a commercial entity. We are a group at the University of Chicago. And what that means is that we follow, of course, all University of Chicago policies and procedures when it comes to storing and protecting data, but it also means for you that if you enter into any legal contracts with us, for example, a data protection agreement, that agreement is with the University of Chicago, not directly with Globus. Globus is a hybrid software as a service. So we have cloud-hosted services that we develop and operate, and we use AWS infrastructure to host those services. And we also develop software that you install locally on your storage system. And today's talk, I'm going to focus solely on the data that we store in the environment that we control. So the data we store in our cloud-hosted environment. Okay, so what is that data? So I'm going to talk about some general categories of data that we store. I'm not going to list out every data type in each of those categories. First of all, we store data about your storage system. So the name of your endpoint, for example, descriptions, keywords, the networking parameters you may have set, what institution it's managed by, for example. We store some small amount of information about your system. So for example, what operating system the endpoint is on, which OpenSSL version it's using. We also store file metadata. So we store the metadata about the files that are involved in transfers. We don't store the files themselves, but we do store some file metadata. For example, we store the file names and paths. We store logs on many different levels. We store data about our users. So specifically, we store name, first and last. We store username, email, IP address, and in some cases, phone and address. We store data from our users. So this is data not about our users, but data that users are giving us, usually through the web forms that are part of our web app. But examples of that type of data are the labels you might give a transfer, the names you might give a bookmark, the name or description you might give a group that you're creating in Globus, for example. If you're running a Globus Connect Server version 4 endpoint, then we cache the X509 certificates. But when they expire or a user deactivates the endpoint, those are deleted. We also store the ACLs or the access control lists for any guest collections or shared endpoints that you're using. So we store the identities of the people you're sharing the data with from those guest collections or shared endpoints. And we store the paths that you've shared with them. And we store the identities of the roles that you may have in Globus. So the identity of the endpoint or collection admin, for example. I want to mention two important data types that we do not store, and one is file contents. I already touched on that. So when you transfer data using Globus, the files are never accessed or seen by Globus. They are not relayed through the cloud. They are moved directly from one storage system to another. As I said, we store some file metadata, but never the actual data or file contents. We also don't store any user credentials, so no passwords. The exception is if you use Globus ID. We do store the Globus ID passwords. That's an identity provider we operate. And I want to say, though, that we don't allow use of Globus ID for access to high assurance collections. So if you are managing sensitive data, the passwords that are being used to access that data are not stored by Globus. How do we protect the data that we store? First of all, what regulations must Globus follow? So what are our legal obligations in terms of data protection? First of all, we follow HIPAA. So Globus as an organization complies with HIPAA. You can use Globus to manage PHI, and it's bad practice to put PHI in file names or paths. However, PHI does leak into file names and paths, and as I said, we do store file names and paths. And so if an institution feels that the risk is high enough that there may be sensitive PHI in those file names, they can enter into a business associate agreement with us, and we agree to comply with HIPAA and protect that PHI. And importantly, we assume that PHI is limited only to the file names and directory paths, that the institution is using high assurance endpoints to manage those files, and that they have entered into a business associate agreement with us. So just because you know that Globus can be used to manage PHI, that doesn't mean that PHI can be put into any type of the data we store. So for example, don't put PHI in your transfer labels or your bookmark names. We also follow any applicable data privacy laws. So for example, for users in the European Union, we follow GDPR. We assume that the PII that you're giving us, or the personal identifiable information that you're giving us, is limited to those fields that we use to collect that information. Name, username, for example. Again, don't put sensitive private information in things like your bookmark names. Okay, and we implement those policies and procedures by using AWS best practices for securing our operating environment. So we really leverage and take advantage of the security features that being in AWS offers us. So for the rest of the talk, I want to go over what those best practices are. I have chosen the ones that people are generally most interested in. There are others, and just because I don't mention it doesn't mean we don't do it. So please do ask at the end of the talk if there are any that you either want to know more about or that I haven't mentioned and you're curious about. So the number one question we get when it comes to data protection is, do you encrypt your data? The short answer is yes. The long answer is we encrypt all public communication with TLS. So that's the communication between your endpoint and our services in AWS, and the communication, for example, between your laptop's browser and our services. We also encrypt the communications between our services within AWS. And for file names and paths that we assume have PHI in them, we also encrypt in transit even within a service. As the PHI traverses through the service, it's encrypted, it remains encrypted. We encrypt all of our data at rest in the protected environment. And by protected environment, I really mean our operational or production environment. And we monitor those encryption configurations within AWS, and then we're alerted if they change. Okay, the second topic we get asked about a lot is access control. And we have a lot of organizational policies to control access. For example, who can authorize access, how that authorization is revoked when someone leaves the organization, policies not to share accounts, policies that make sure that only the people who need access get access. But here I want to focus more on the technical access controls. And the first type of access I want to talk about is access via the network. And we control that access using a number of layers. The first layer is we isolate our services in separate AWS accounts. There is no one big Globus AWS account. Roughly speaking, each service has its own account. Then we define the network between and within the accounts and the public internet with a combination, again, a layer of VPCs, subnets, and AWS security groups. I'm going to talk about that in the next slide briefly. Here I just want to point out that our private network, which is what allows privileged access, access always goes through our VPN, which uses certificate authentication. We use VPCs and subnets to create network isolation. So for example, we put our databases in subnets that don't have any connectivity, inbound connectivity to the public internet. Our different services are also in different subnets, so they're on different networks. We use AWS security groups, which you can think of as the firewalls that define the allowed ports and protocols between networked entities, and not just between the different subnets, but also between EC2 instances, between individual database instances, load balancers. So AWS security groups gives us the ability to create a very very granular network. The second type of access control that I think is important to talk about is AWS API access, just as important as network access. And we manage that through a dedicated account for managing access to the API. In that account, Globus staff members who need to access our protected environment using AWS services, each staff member is represented as an IAM user. Those users are placed into groups as appropriate, and then those groups are assigned permissions to assume roles, which provide access to the AWS API. The role credentials are short-lived, and all of this access requires MFA as well as management of the access. We produce logs at multiple levels, and we centralize those logs. The logs are monitored to make sure that the logging is occurring and that there are no missing log sources, and we get alerted if logging fails. The logs are encrypted, and we have a 90-day rotation policy for our logs. We monitor our network, and we run agents on all long-lived EC2 instances. Those agents send the telemetry to a third-party managed security service, which monitors the telemetry and alerts Globus if they detect anything suspicious. I've mentioned monitoring a couple times already. I wanted to just mention two other ways that we monitor. We do file integrity checks, and we have a number of conformity monitors to make sure that our baseline configurations are being met. So we are alerted, for example, if whenever AWS security groups change, or a port configuration change, or there's been a change to an IAM role, for example. And those alerts are sent to logs and to our staff. We do daily vulnerability scans and have a 90-day security patch cycle. And of course, if there are urgent security patches, we patch out of cycle. Our workstations, or in our case, probably almost exclusively our laptops, all conform to a baseline configuration of full disk encryption, antivirus, regular security patches. The firewalls are on, password protected. We sanitize the hardware before we repurpose it or dispose of it. If there's an incident, despite all the data protections I've just described, we have an incident response plan, and of course we can leverage the entire University of Chicago IT security team if there ever were to be a serious incident. And we've done some tabletop exercises to test that incident response plan. And if there is truly a disaster, we have periodic snapshots of our services, and we store those in a very heavily isolated AWS account. And that's the end of this talk, and happy to take questions either on this topic or any other. Thanks.